Okay, so we've just finished looking at the quotient rule and using it to do one derivative. Let's take a look at the proof for this rule. We're going to take our original function, which is expressed as h of x equals f of x over g of x. We know what we're supposed to get, so our goal is to have f prime of x times g of x minus g prime of x times f of x all over g of x squared. Now if you remember your proof from the product rule, we went back to the first principles definition of the derivative. So that's that whole limit as h approaches 0, f of x plus h minus f of x all over h. The good thing is that with a couple of slick moves here, we don't actually have to go back to first principles. So the first thing we're going to do is we're going to change that original function to a product. Okay, so h of x equals f of x over g of x. We're just going to multiply up g of x to the other side there, and then flip around the order here. So then we have f of x equals g of x times h of x. The advantage of doing this is that despite the fact that we don't have a rule that we've proved for the quotient rule, we do have a rule for the product rule. So if we have that, we can use our product rule to differentiate this function. And if you take a close look at this derivative, the derivative is going to be the derivative of the first times the second plus the derivative of the second times the first. So g prime of x times h of x plus h prime of x times g of x. Now if you take a good look at this, it kind of has some of the ingredients we need if you look at our goal. It's got f primes, it's got g primes, it's got f's, it's got g's. Actually it doesn't have f, but anyway. But this is the thing that we're trying to show is equal to that red goal at the top. So if we take this function and rearrange it for h prime of x, this is what we're going to get. So this would have happened in a couple of steps. The first thing you would have done here was you would have taken g prime of x times h of x over to the other side, and then when you had h of x times g of x, you would have divided by g of x, and that would have isolated h prime of x by itself. Okay, so we're getting there. You can see we kind of have some pieces in there, but a glaring issue you should be seeing here is the fact that we have h of x in this function, which is right here, and we don't want it. Okay, if you look at what we're supposed to have up here, there's no h of x in there. So what we're going to do is we're going to get rid of that. So we are going to replace h of x with what it's equal to, which is f of x over g of x. So we're just doing a substitution here, taking the expression f of x over g of x and replacing h of x with it. So that's what's happened there. So now we have f prime of x minus g prime of x times f of x over g of x. And the whole thing is over g of x. So we're getting there. We kind of have all the right pieces, but now we've got, a fraction in the numerator, which we don't really want. How we can handle that is we can multiply the numerator and denominator of this function by g of x. Okay, so, and if we look kind of carefully at what that does, this is a binomial in the numerator, so both of these terms are going to be multiplied by g of x. Okay, so when you do that, here's what you get. So when you multiply g of x times f prime of x, you're going to get f prime of x times gx. Okay, that's your first term there. And then for this next part here, I'm looking at specifically this part here. Okay, the numerator there. When you multiply g of x times f of x over g of x, the g of x's cancel out, which I'll show you kind of temporarily here, but I'm going to get rid of that because it doesn't cancel because you have to multiply with the other one. But those two cancel out, and then you're left with g prime of x times f of x. In the denominator, you have g of x times g of x, which is g of x squared. So that's it. We've proved that that function works, and it's a much less messy proof than our product rule proof was, if you can remember that. So yeah, that one's not too bad. Let's apply this derivative rule then to another function, just to get a bit of practice with it, because it is sort of awkward. Okay, so the next function we're going to do is 3x squared plus 2 over 2 minus x squared, and we're going to differentiate this using the quotient rule. So I'm going to grab the memory method for the quotient rule and drag it out and change that to an arrow, because that's not right. Okay, and we'll take a look at this one carefully and think of all the pieces. And actually, maybe what I'll ask you to do is try to differentiate this one on your own. Okay. Now I know the original function is f of x, and I've got an f and I have a g, but hopefully you can just ignore the duplication of those letters there. Just write f prime of x here on the left-hand side, and then just think of f and g when you're doing your derivative. So I'll give you a moment to just go ahead and see if you can apply the rule. It's really hard to tell whether that's long enough when I can't see anyone doing it, but I'll take a look and jump in here now. So if you're taking a look at your derivative, I'm just going to move this down so we have a little more room. Okay, so what I'm going to do first is the derivative of the top. So the derivative of 3x squared plus 2 is 6x times the bottom as is, which is 2 minus x squared. Minus, because it's always subtraction in the quotient rule, the derivative of the bottom, which is negative 2x, times the top, which is 3x squared plus 2, all over the bottom squared. Whoops. Try that again, all over the bottom squared. Okay, and I'm going to go ahead here and write in some letters. So this part is f prime, that part is g, this part is g prime, that's f, and notice here this is over g squared, okay? Not the derivative, just straight up g whatever it was to begin with. Okay, the denominator you're going to leave because it's factored, okay? Expanding the denominator is not better, particularly in a rational function. You want to see opportunities for canceling, and you can see that best when stuff is factored. Your numerator, however, isn't even close to being factored, so we're going to expand and simplify that. So 6x times 2 is 12x. Then we're going to have minus 6x cubed if I expand that in. Those two negatives there change to a plus. So I'm just going to circle that. So I'm just going to think of that as being a plus and then distributing in. So I've got plus 6x cubed. That's handy. It's going to cancel out. Plus 4x. Okay, that's what we should have there. And if we clean that up, the 6x cubes cancel out. 12x plus 4x is 16x. 2 minus x squared squared, we're going to leave. Okay, and that's your derivative using the quotient rule. So there's kind of two big steps in every quotient rule. The first line is where you apply the rule and you get a big mess. And then after that, you need to go through the work of cleaning it up. And depending on the complexity of the function, sometimes the cleanup is a lot of work to do. And in the next example, which I think I'll put in the next section of the lesson, the cleanup is super awkward. So we're going to take a look at that so you know how to do those next.